Sometimes histograms are confused with bar graphs. Well, they're not bar graphs, okay? So let's find out what they are and how to create them. Welcome once again to the Intro to Stats 5-minute lecture series. Let's hit that timer and get started. So this, folks, is a bar chart. Notice how there's spaces between each of the rectangles. That's usually a good indicator that it's a bar chart. But more importantly, notice that the headings or buckets are categorical. In other words, you could switch any one of the color buckets and the way the chart looked would change, but the chart would still be correct. For example, if the blue was switched with yellow, the chart would look different, but it wouldn't be wrong. And this, my friendly nerds, is, by contrast, a histogram. Notice, typically there's no spaces between the rectangles, and the x-axis contains quantitative data. Keeping the order of the data allows us to have a graph that doesn't change and is only correct if the values are in order. These are the main characteristics that distinguish the bar chart from the histogram. All right, so let's more precisely define what a histogram is. A histogram is a tool whereby we can get an accurate visual representation of the distribution of the data we're working with. It'll probably be best to see an example. Once again, to show you an example, I'm going to use Excel, but these can easily be done by hand following the manual steps I will give you. So in this data set, we found the salary for 20 random White House personnel. Just seeing the data in tabular form like this doesn't give us a sense for how the data really looks. This is where the histogram comes in. When starting to create a histogram by hand, we need to consider the number of buckets or bins to use. First, let's talk about bins, sometimes called intervals or buckets. It's important to figure this out since it'll completely determine how the data will be visualized. Here are some general rules. 1. Each bin should have the same width, whether it be 5 or 500. This is very dependent on the data points you have. Bins should include all of the data. All means even the outliers should be there. Boundaries for bins should land at whole numbers whenever possible. Try to stick to between 5 and 20 bins. The larger the data set, the more likely you'll want to use large numbers of bins. For example, a set of 12 data pieces might warrant 5 bins, but a set of 1,000 numbers will probably be more useful with 20 bins. The exact number of bins is usually a judgment call. However, you can use a method called Sturge's rule to help. For our purposes, however, we'll just stick with the judgment call method. And finally, if at all possible, try to make your data set evenly divisible by the number of bins. For example, if you have 10 pieces of data, work with 5 bins instead of 6 or 7. So back to our example. So here I've added the bin creation steps as well as the salary data from the original data. First, let's find the min and max values from the data. There are 2 methods. We can sort the data and take the first and last values, or in Excel we can use the min and max function. Next, we'll grab a rounded value below the min and a rounded value above the max. So let's use 40,000 for the min and 180,000 for the max. Then we should decide on the number of bins to use. In this case, we'll use 5. Next, we'll divide the range to use, which is the max value to use minus the min value to use. And this will be our bin sizes. And finally, to create the actual bins, we'll start with the min, then add the bin size for the bucket width. Do this for each boundary. Next, we need to figure out how many things go into each bin. First, let's create a column next to salary that shows what bin each salary goes into. Notice that there is a value of 124,000 that falls right on the borders of the bins. This, of course, points out the need to decide which boundary will be inclusive and which will be exclusive. In order to show this, I'll change the from title to be inclusive and the to title to be exclusive. So in this case, 124,000 will be in the 4th bin. After this, we'll add up the number of salaries in each bin. We could, of course, do this manually, or Excel has a function, COUNTIF, where you put in the range of the cells you want to count and then the cell that contains the value you want to filter for. Confusing? That's okay, you can just manually count them if you'd like to. Finally, we draw the histogram based on the frequency and the bin's information. On the y-axis, we have frequency, which is really the count of items in the bins. And on the x-axis we have salaries, where the points on the axis are the boundaries of the bins. Notice that we can create rectangles that represent the data. For bin 1, the frequency of 9 could be made into a rectangle of height 9 and width from 40,000 to 68,000. Continue this for each of the bins and voila, we have a histogram. And so there you have it, the creation of a histogram from data. Hopefully you can easily see that we get a better sense of what the data looks like, or the distribution of the data. Cool, so I think that about covers it. And now you know how to create a histogram. Granted, throughout this example, I used Excel. I'm hoping you can clearly see that doing this by hand wouldn't be the worst thing in the world. That was amazing. Thanks for watching. Feel free to leave any questions or comments in the comment section below. Don't forget to like and subscribe if you're into that sort of thing. In the next video, we're going to look at stem and leaf plots. It's so pretty, huh? It's very pretty. I like it a lot. It's very pretty. I did not hit her. I did not. Going a little bit loopy.